This is second video in continuation with first video. In first video, I have discussed about types of reservoir, investigations carried out for reservoir site selection, zone of storage, and yield, safe field, and other classification of yield. In this video, we will discuss about reservoir capacity and reservoir sedimentation. Reservoir capacity. It depends upon the inflow available and demand. Inflow in the river is always greater than the demand. There is no storage required. If the inflow in the river is small but the demand is high, a large reservoir capacity is required. So the required capacity for a reservoir can be determined by the following methods. First is graphical method using mass curve, and second is analytical method. So the reservoir is required to satisfy the demand, and if demand is more and the amount of water in the river is less compared to demand, then large capacity reservoir is required. So how we will find out the reservoir capacity? Let's see graphical method. So in graphical methods, two curves are plotted. First is prepare a mass curve or mass inflow curve from the flow hydrograph of the site for a number of consecutive years, including the most critical years. Means most critical year is the driest year when the discharge is low. So first mass curve is prepared, and mass curve is the flow hydrograph, means how much amount of water or the water rainfall accumulated versus year time. Prepare the mass demand curve corresponding to the given rate of demand. Second curve is demand curve, and based on demand curve is prepared. If the rate of demand is constant, the mass demand curve is straight line. Obviously, if the demand is constant, the demand curve is straight line. The scale of the mass demand curve should be the same as that of mass inflow curve, right? So in one plot, mass curve and demand curve is plotted. So here there are two curves. Okay, on x-axis year, on y-axis accumulated inflow. So this is mass curve. Mass curve is prepared with the help of inflow, the amount of water collected at particular site, and this is demand curve. We are considering the demand is constant, therefore this is demand curve which is of straight inclined line. Okay, here the both the curves are of same scale, right? So this is graphical method to find out reservoir capacity, in which we have to prepare two curve. One is mass inflow curve from river inflow, and second is demand curve based on demand. So these are the steps which are to be followed to determine the reservoir capacity. Let's see. So first draw the line AB, FG, etc. such that they are parallel to the mass demand curve and they are tangential to the crest AF, etc. of the mass curve. So let's see these steps from the graph itself. Okay, first draw the line AB and FG. These lines are parallel to the demand curve. So with the help of ruler or set square, draw a parallel line AB and FG parallel to demand curve. Okay, from where? From this peak point of mass curve, right? So they are parallel to mass demand curve AB and FG. They are tangential to the crest A and F, right? So this is the tangent point parallel to demand curve. Okay, so these two lines are prepared. Determine the vertical intercept CD, HG, etc. between the tangential line and the mass curve. Second step, draw vertical intercept CD, HG. How? There are 2 points. They touch 2 points. First, they are tangential line, intercept to the tangential line and the mass curve, right? These intercepts indicate the volume by which the inflow volume fall short of the demand. This point said, see, this D point on mass curve. What is mass curve? It indicates the inflow in the river. So this indicates the amount of water in the river. C point. C point on demand curve line. So this indicates the demand, right? So D is the flow in the river and C is the demand, right? So what happened? It shows shortage of demand. Now, next step. Assuming that the reservoir is full at point A, the inflow volume during the period AE is equal to ordinate DE and the demand is equal to ordinate CE. See, A is the highest point, A is the highest point, right? Means the reservoir is full because A is on mass curve, right? So A is the highest point, means reservoir is full. Now inflow volume during period AE line is drawn, is equal to ordinate DE. So CD is equal to DE, right? Thus the storage required is equal to the volume indicated by intercept CD. So C is the demand and D on the reservoir, matlab on river inflow. So what is the demand? How much shortage is there? CD. CD is the shortage of demand. Determine the largest of the vertical intercept found in previous step. So based on the continuous that mass curve, which intercept is largest, whether CD or HG? The largest of them is calculated. The largest vertical intercept represent the storage capacity required. So this much amount of storage is required because at this time period we have water in the river is equal to at D and C point indicate the demand. So CD indicate the shortage of water, right? So that much capacity of reservoir is required. So I hope it is clear that by preparing mass curve and demand curve and draw a parallel line to the demand curve from the tangential point and the vertical intercept indicate the shortage of demand, means that much amount of capacity of reservoir is required. Second is analytical method. Capacity of reservoir is determined from the net inflow and demand. Storage is required when the demand exceeds the net inflow. The total storage required is equal to the sum of storage required during the various period of time. So these are the steps of analytical method. Collect the stream flow data at the reservoir side during the critical dry period. Generally, monthly inflow rates are required. However, for very large reservoir, the annual inflow rates may be used. Ascertain the discharge to be released downstream to satisfy water rights or to honor the agreement between the states or the cities. Determine the direct precipitation volume falling on the reservoir during the month. Estimate the evaporation losses which would occur from the reservoir. The pan evaporation data are normally used to estimation of evaporation losses during the month. Ascertain the demand during various months. So inflow minus outflow is the evaporation losses and demand. So determine the adjusted inflow during different months as follow. So adjusted inflow is equal to stream flow plus precipitation minus evaporation minus downstream discharge. So compute the storage capacity of each month for each month. So storage required is equal to inflow minus demand, right? So determine the total storage capacity of the reservoir by adding the storages required found in previous steps. So it is same as continuity equation, or we can say water budget equation, that inflow is equal to stream flow plus precipitation minus evaporation minus downstream discharge, right? So this is how we can find out the reservoir capacity with the help of these two methods. Let's see how we will find out the yield. So yield, again, it is almost same. The yield from the reservoir of the given capacity can be determined by use of mass inflow curve. Means it is hydrograph. With the help of hydrograph, it is same method as we have discussed in graphical method, right? It's the same as this. So shortage capacity that we have already discussed in previous topic. So that's next topic is causes of sedimentation, right? So what is sedimentation? First we have to discuss what is sedimentation. So sedimentation is nothing but the process of deposition of sand and silt in the reservoir, right? It is known as sedimentation. Now in the catchment area, if the soil is loose or sandy soil, right, so that runoff water carry that sand and silt with it, and that sand and silt flow with river water. So ultimately at the dam side, the all sand and silt carried by the river water are get deposited into the reservoir. So this process of deposition of sand and silt is known as sedimentation, which ultimately reduce the capacity of the reservoir, and sedimentation is not advisable. So these are the reasons of, or the causes of sedimentation. Now the reasons are nature of soil in the catchment area, topography of the catchment area, cultivation in the catchment area, vegetation cover in catchment area, and intensity of rainfall in the catchment area, right? So before discussing the causes, let's say this figure. So this is how the sediments get deposited in the reservoir. Actually the sediments are of two types. One is suspended and another is bed load. Barabar. Suspended are the debris and floating debris are there. So small size sediments or silt and sand are in suspension with the water, while large size sand and silt, or we can say boulders, are deposited into the bed of the reservoir, right? So this is, we can say, bed load sediment, and these are the suspended load sediments, right? So at the upstream or upstream most point, the water become turbid and the sediment get deposited slowly and slowly on the bed of the reservoir, and relatively clear water is available on top of the dam, right? Right. Now one more term is there, density current. Density current may be defined as a flow of one fluid under another fluid of slightly different density. So different density fluids are flowing together, and it is known as density current. So this figure shows how the sediments get deposited in the reservoir. Now let's see the causes. First cause is nature of soil in the catchment area. If the soil in the catchment area of a river is loose and easily erodible, the river will bring in large amount of sediment, right? If loose soil is there, sedimentation is more. On the other hand, if a river carry less sediment, if the soil in the catchment area is hard or rocky, then sedimentation is low. Second cause is topography of the catchment area. Topography means steep slope or flat ground. If the catchment area with steep slope, high velocity of flow is there, hence cause more erosion of soil, subsoil, then sedimentation is more. If the ground slope is flat, the velocity of flow is less, sedimentation is less, right? Cultivation in the catchment area. The intensive cultivation in the catchment area will make the soil loose. If the soil get loose, rainwater will carry lots of sediment, right? Such river carry more sediment. Next is vegetation cover in the catchment area. If the catchment area is covered with vegetal cover, like grass, plants, forest area is more, then the erosion of the soil will control and river carry less sediment, right? Or if the catchment area having poor vegetal cover, erosion will be more and more sedimentation. Intensity of rainfall in the catchment area. So if the intensity of rainfall is high, then increase the rate of runoff and more erosion is there, river carry more sediment and sedimentation is high for the reservoir. So this is the relationship of these factors with sedimentation, right? That we have to discuss likewise. So how we will manage or control this sedimentation or sediment? So maximum efforts should be made that water should be released so that less sediment should retain in reservoir. So options for managing sedimentation are the catchment vegetation, as we have discussed earlier that vegetal cover reduce the erosion and thereby we can reduce the sedimentation or sediments in the river, right? So increase vegetal cover to reduce erosion of soil and thereby reduce sedimentation. Construction of coffer dam or low height barriers. So before, on the upstream face of the reservoir, some small height dams are constructed which does not obstruct the flow, but at that barrier or the small height dams, low height dams, uh, the sediment get deposit over there and relatively clear water flow from them, and relatively less sediment comes in the reservoir, right? So on the upstream side of the reservoir, one can construct coffer dam or low height barriers. Flushing and desilting of sediment means removal of sediment is also done. This is a curative measure. Sediment already deposited in the reservoir may be removed either by excavation or through the scouring sluices, right? Low level outlets and sediment sluicing. Outlets are provided at the lower level of the dam. So by opening the outlets, the dirty water or turbid water get flow at the downstream side, and thereby we can reduce the sediment deposition, right? So these are the measures are taken to remove sediment or to control the sediment deposition in the reservoir, and thereby we can save the reservoir capacity or increase the useful life of the reservoir, right? So this is the end of our session of reservoir. So my next video of same module is introduce you with them, right? So this is part 2, or we can say second video of reservoir, and my next video is all about them. Thank you.